Hi, today we're going to be talking about rate conversion, which is a common problem or exercise that you have to do in working with algebraic units, especially when dealing with distances, rates, times, moving things, that sort of thing, right? So say I'm driving along the road and I'm traveling a certain distance, and I find I was traveling at a rate of 5 meters a second for 10 seconds. Let's say this is a very small interval. How far did I travel in that interval? Well, I know distance, how far I traveled, is equal to rate times time, which is equal to 5 meters per second times 10 seconds. And if we were to imagine these meters per second and seconds as sort of algebraic units, we could, cancel them. We'd have something like 5 times 10 times meters per second times second. Of course, the seconds in both the numerator and the denominator, so they cancel out. And I'm left with 50 meters as my total distance. Right? That seems easy. But why do I need to worry about rate conversion? Well, what if I was traveling at a rate of 5 meters per second, but I wanted to know how far I traveled in 1 hour? Right, so now my distance is 5 meters a second times 1 hour. And so if I were to just multiply them straight across, I'd have 5 meters per second hours. That's a weird unit. That doesn't make sense. What on earth is this going to be? Right? Well, I have to find some way of converting these seconds into hours, right? So I can get the unit that I want and just get meters, right? Because I know my final answer, just like before, should be in meters, because meters is a measure of distance. So how can I cancel out these seconds and hours? Well, I know that there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour, right? Now, what I can do is that since if I were to do it, these are basically equal to 1, right? Because 60 minutes is equal to 1 hour. 60 seconds is equal to 1 minute. I can take these and multiply them by my units to get an appropriate value, right? So 1 hour is equal to times 60 minutes over 1 hour. That cancels out the hour. And then times 60 seconds in 1 minute. That cancels out the minutes. And so now I'm left with 5 meters a second times 60 times 60, or 3,600 seconds. Now I've got seconds in the numerator, seconds in the denominator. I can cancel that out. I'm left with 5 times 3,600 meters, or 18,000 meters as my final distance. And that's just wonderful. I've taken this huge mess, this meters per second, hours, and got it into something nice and clean. But let's say that wasn't good enough, right? I wanted my unit, I wanted to be in kilometers, right? Well, I have 18,000 meters, right? And I know that there are 1,000 meters in 1 kilometer. So what can I do with this? I can say I'm going to multiply that by 1 kilometer over 1,000 meters, right? And since these are equivalent, I'm really just multiplying it by 1. And I can multiply it by 1 without even worrying about changing its value, because anything times 1 is itself, right? Well, I have meters in the denominator here, and meters in the numerator here, so I can cancel them out. Then I have 18,000 kilometers over 1,000, which is 18 kilometers. And so it's just like that. I've used these sort of fractional rates, what we call rate conversion, to turn meters into kilometers and meters per seconds and hours to nice convenient units that can make our process a lot easier. So let's keep going with this, and let's try to do more of this. So say I'm driving in a car again, and I've traveled 150 kilometers, very long trip, in 3 hours. And I want to know my rate, my average rate. Well, I know distance equals rate times time, so my rate is going to be distance over time, right? Which is going to be 150 kilometers divided by 3 hours, or 50 kilometers an hour, right? But say I wanted to know what my rate was in kilometers per second. What am I going to do then? Well, I'm going to need to get rid of this hours and just get it and convert it back into seconds. So, 50 kilometers an hour. And as we learned from the previous problem, there are 3,600 seconds in an hour. Simply put, because there are 60 minutes, there are 60 seconds in every minute, and there are 60 minutes in every hour. So that ends up with giving us 3,600 seconds in an hour, right? So now we have, multiply that by 1 over 1 hour over 3,600 seconds. Because this is 1, we can multiply this without worrying about changing the value. Now we have hours in the numerator and hours in the denominator, so we can cancel them out. We're left with 50 kilometers over 3,600 seconds, which comes out to 1 over 72 kilometers a second. And just like that, we converted kilometers per hour into kilometers per second, right? But let's say, now, we don't want kilometers per second, we want meters per second. That's a better unit. What are we going to do then? Well, we have 1 over 72 kilometers a second. We want to make this meters. We know that there are 1,000 meters in 1 kilometer. So this is 1. I want to put my kilometer in the denominator so I can cancel it out from the kilometer in the numerator. And so I'm left with 1,000 in the numerator, 72 in the denominator, and meters divided by second. So I traveled 1,000 over 72 meters per second. And unfortunately, there isn't a great, perfect simplification of this. So I'm just going to leave it at that. But that is the magic of rate conversion. So if you're given a problem that gives you different types of units, and then asks you to give your answer in a different type of unit, well, you can use rate conversion to make those units align to what your answer needs to be, right? So if your answer needs to be in meters per second, for example, and you were given, as you were originally, kilometers and hours, you can do that rate conversion and make your process a whole lot easier, and you can get the right answer. So that's all. I hope you found this helpful, and I hope you have a great day.